Okay, in this last video, what we're going to do is put both of those skills together. So what I want you to do in your notebook is I want you to make this similar table with polynomial, GCF, and factored form at the top. Our goal is to find the GCF and then write our polynomial that was in standard form and rewrite it in factored form. So kind of a two-part thing. We need to find the GCF and then we need to rewrite it in its factored form. In the first example, we see 10x squared plus 8. So the first thing that I needed to do is figure out what the GCF is going to be between 10x squared and 8. So remember what we were doing before to find the GCF is think of things that multiply to 10. Well, 1 and 10, 2 and 5. And then we need to think of things that multiply to 8. 1 and 8, and 2 and 4. If we look at the greatest common factor, what is the greatest number that they have in common? I can see that the greatest common factor is going to be 2. I also notice that the 8 doesn't have an x after it, so x is not in common. So the GCF is just going to be the number 2. Now, think that I have 10x squared plus 8, and I'm taking out a 2 from both of them. So in a factored form, I have 10x squared plus 8. I'm dividing both of these numbers by 2. To figure out what's going to be remaining, I have 2 on the outside because it doesn't magically disappear. What's remaining is 5x squared plus 4. How did I get 5x squared? Well, I divided 10 divided by 2. How did I get the 4? I did 8 divided by 2. I can always redistribute to check my work. Remember, 2 times the quantity 5x squared plus 4 is my answer in factored form. I'll highlight that because that's my answer. I can recheck it to make sure I get that original polynomial back. Let's try example 2 together. I'm given 6x to the third minus 12x. So once again, I need to figure out the GCF. To figure out the greatest common factor, we want to figure out things that multiply to 6. Well, 1 and 6, 2 and 3. And I want to think of things that multiply to 12. 1 and 12, 2 and 6, 3 and 4. Notice they have the 1 in common. They have the 2 in common, they have the 3 in common, no 4 in common, and they have the 6 in common. 6 is the greatest common factor between them. Now, if I compare x's, x to the third and x to the first, I want to take the lower of them because that's what they share in common, so it's going to be x to the first. So my greatest common factor should be 6x. So I have my polynomial, 6x to the third minus 12x. And I want to take out a 6x from both of them. So I'm going to divide both of these terms by 6x. When I write it in factored form, that 6x goes out in front. Doesn't magically disappear. To figure out what's remaining inside that parentheses, I divide the coefficients to the numbers in front, and I subtract the exponents with the same base. So once again, I divide the coefficients, the numbers in front, and I subtract the exponents with the same base. So 6x to the third divided by 6x just gets me 1x squared, or x squared. 12x divided by 6x gives me that 2 because the x's cancel. So my final answer in factored form is this 6x times the quantity x squared minus 2. Let's look at that third example, 15p minus 10. What I need to do is find the greatest common factor between 15 and 10 as my starting point. So listing things that multiply to 15, 1 and 15, 3 and 5. Things that multiply to 10, 1 and 10, 2 and 5. I can see they both have a 1 in common, no 3 in common, no 2 in common, but they both share this 5 in common. There's no variable that they share in common, so my GCF is just the number 5. When I move over to the factored form, I have my polynomial 15p minus 10. Each of those terms, I'm taking out that greatest common factor of 5. So what I'm doing is dividing both of those pieces by 5. That 5 that I factor out goes out in front. To figure out what's remaining inside that polynomial is I divide both those pieces, both those terms, by 5. 15p divided by 5 gives me 3p. 10 divided by 5 gets me 2. So my final answer in factored form is 5 times the quantity 3p minus 2. Now, example 4 is a little different because notice there's no numbers. It's just the variables y squared minus y. When I'm comparing variables with the same base, I want to take the lower exponent. So my GCF is just the y, or y to the first. When I want to determine my answer in the factored form, I start with my polynomial, y squared minus y. And each of these, I'm taking out a y, or dividing by y. So that y, that's my GCF, goes out in front. It doesn't magically disappear. To figure out what's remaining inside that polynomial, I'm going to divide both these terms by that GCF of y. Y squared divided by y gives me y to the first, and it's very important. Y divided by y gives me 1. I need that as a placeholder because if I redistribute and check my work, I want to make sure that I'm getting that y squared minus y. If I don't put that important -1 there, I'm not going to get that binomial back. So it's very important to have that term, that -1, as my placeholder. So y times the quantity y minus 1 is my answer in factored form. Remember, standard form is when I go from highest exponent down to that constant if there is one. Factored form, I'm factoring out that GCF, and that remaining parentheses is to figure out what's remaining in that polynomial. We have 2 more examples we're going to look at together. Here we're looking at a little bit tougher. 20a to the third b squared plus 35a squared b to the fifth. Just like the first couple examples, I have to figure out the GCF, or the greatest common factor, between 20 and 35. So 1 and 20, 2 and 10, 4 and 5. Between 35, just 1 and 35, and 5 and 7. Remember, if you get stuck, in our notebook should be that multiplication chart that we can use. I see they both have a 1 in common, and I see they both have a 5 in common. Now I need to compare the a's. A to the third, a squared. I want to take a squared. Now I need to compare the b's. B squared, b to the fifth. I want to take the lower, so I want to take b squared. So my GCF should be 5a squared, b squared. Now, let's figure out what my polynomial looks like when I rewrite it in its factored form. I have my polynomial that I started out with. Each term I'm dividing by this GCF of 5a squared, b squared, which is what I have right here, to figure out what's going to be remaining. When I rewrite this, that GCF goes out in front every single time. Here, take it by piece. 20 divided by 5 gets me 4. A to the third and a squared. I'm subtracting those exponents. So I get a to the first, or a. B squared and b squared, they cancel out, so I don't have to write it. Now let's look at the second term. 35 divided by 5 gets me 7. A squared divided by a squared, they cancel out. I don't write anything because that would give me a to the 0, which we remember is just the number 1. And then b to the fifth and b squared, I'm subtracting, so I get b to the third. Just like we did in that previous video, I can always redistribute to make sure I get this original polynomial back. So my answer is 5a squared b squared times the quantity 4a plus 7b to the third. Last example, before we try some on our own. X to the third plus 8x squared plus x. Well, here I notice they don't have any numbers in common, no greatest common factor, but I have an x to the third, an x squared, and an x to the first. I'm comparing those variables to figure out the greatest common factor. I see that I want to take the lower of the exponents, so I want to take that x to the first. So my greatest common factor is just x. So here I start with my polynomial, and I'm trying to rewrite it in factored form, which means I'm going to divide each of those terms by x. The GCF always goes out in front. Now each one, I'm just going down 1 degree for my x's. Everything else is going to stay the same. X to the third divided by x is x squared. 8x squared divided by x is just 8x. And x divided by x, just like we would say 5 divided by 5, is going to get me 1. This is very important to put that +1 there, because when I redistribute to check my work, I want to make sure that I get that trinomial back. So my answer in this factored form is x times the quantity x squared plus 8x plus 1. So let's try some practice problems.